In this video, we want to learn on how to derive the speed of a wave on a string. So the speed of a wave on a string is given by the following equation. V equals to the square root of a t over mu, where our mu is the mass per unit length. So when we check in this diagram, we are given an infinitesimal element of length, the x, which forms part of the circle. This is the part of a circle. And then of radius r, so this is the radius r. Then since there are two, we can call them radii. So we can see that both on the left and on the right we have the tension. We have this tension and we also have this tension. And these two tensions are acting at some certain angles. We have this angle and we also have this other angle. The two angles are considered to be equal because this tension that is over this part is the same tension that will be present in this side. So since when we check here, this tension is acting at a certain angle and also this one is acting at a certain angle, then we can find the components of this tension, because we cannot pull this object up or down, because when we check here, the tension is acting at a certain angle. So we want to know the amount of force that will extend or expand this object over the x-axis and over the y-axis. So let us find the components. So this is the object for now, or the element. It's very small. So this is the element. So the tension, and then we have our angles here. All right, so we want to find the amount of force that will act on this element on the x-axis. So if this is our angle, it means here we must have t, the cosine of the angle. This one will be on the x-axis, and on the y-axis, then we'll focus on the y-axis. So we have t, the sine of the angle for this tension. So also for this tension over here, we are going to have t, the cosine of an angle, and then on the vertical axis, we are going to have t, the sine of an angle, like this. So we can see that this element forms part of the circle. Then it also subtends the radius to the center. So from this point to this point over there, we have theta, and also this side is our theta. So the length is the s, and then this is what? This is our r. So for now, let us find the components of these elements that will be present in the x-axis. So in the x-axis, we consider this line. We can see that we have t cos theta and we also have t cos theta. The two are equal from the point of reference. Therefore, the sum of the forces on the horizontal the horizontal components, we have t sine theta, then plus, because this one is in the opposite direction, it will be minus t sine theta, like this. So because the two are equal, then there will be t sine theta, or sine, this is sine theta, minus t sine theta, like this. They are the same. So the sum of the horizontal components, since they are in opposite directions, then they add up to 0, which act on this element. Then let us also find the sum of the vertical components. So the sum of the vertical components will be this one and also this one. So let us note down the sum of the vertical components. So the sum of the vertical components will have t sine theta, because they are in the same direction. So we also have t sine theta for this one, t sine theta. The two are the same, so they can add up to 2t sine theta. So this tells us that in this object, the only force that will cause motion is this one, the 2t sine theta. And since it's in the vertical direction, and this object moving in the form of a circular motion, it means that it will cause this object to accelerate towards the center. So since this object is moving in a form of a circular motion, we know that object moving in a form of a circular motion, they have what? The radial acceleration, and the radial acceleration is given by v squared over r. So it means that the force that will cause this object to accelerate towards the center is the radial force. So this is Fr. So now our Fr is 2t sine theta. Then now we can write our radial force this side. Fr is equals to 2t sine theta. Remember, we are dealing with an infinitesimal element, so it's extremely very small. So for small angle approximation, we know that sine theta is approximately equal to theta. So in space of tan theta, then we are going to write theta. So Fr is equals to 2t theta, like that. So this is what we have. So I have said that this object, as you can see, that it forms an arc, or is part of the circle. So this is what we have. Subtends an angle of 2 theta at center, because this one here is a theta, also this one is a theta. Therefore, the total angle here is 2 theta. This is our radius, and then our distance, the x. We know that when we want to find the angle of an arc, is given by, let me write it down here. This is 2 theta equals to the opposite part. This one is the s, then divide by the hypotenuse, which is the radius. So from what we have here, we can say that the s is 2 theta multiplied by the radius. So this object is modeled under net force, and since it's modeled under net force, then we also have to apply Newton's second law, because we have the force. So from Newton's second law, force is given by mass multiplied by the acceleration. This is mass multiplied by the acceleration, which is equals to 2t theta. So remember, we have said that this object experiences a radial acceleration. The acceleration is given by this form. So in space of a, we can substitute v squared over r. So m is equals to m multiplied by v squared over r will be given by 2t theta, like that. All right, so this is what we have for now. This is a very small element. It's a very small element, so we have to find its mass per unit length, the mass per unit length of this element. So how can we find the mass per unit length? The mass per unit length is given by mu. Mu is equals to the mass of this object per unit length. So the length is given by dx. It's the s, not the x. Which implies that, so the mass of this object will be will be found by multiplying the mu and the length ds like this. So checking that ds is given by 2 theta multiplied by r, we can substitute 2 theta multiplied by r in space of ds. So the mass will be given in terms of mu. So in space of ds, I will have 2 theta multiplied by r. This is 2 theta r. Then can be generalized in this form. This is 2 mu and then theta multiplied by r. So this is the mass of this element. Then now we can have in space of m, we can have these terms over there. So this will be 2 multiplied by mu theta r, and then v squared over r. This is given by 2t theta. Then you can see that from here 2 will cancel 2, and theta can cancel theta because they are the same. And then what else? And then r will also cancel r. And then on the left we have mu v squared. This is given by t. We want to find the speed of a wave, so we have to find v. So v squared is given by t divided by mu. Therefore, taking the square root both sides, we can see that our v will be given by the root of t over mu. So what we just derived right now here is the speed of a wave on what? On a string. So if you find this video very useful, don't forget to subscribe to this channel and like this video. Thank you.